All right, hello everyone, this is Mr. Crozier. I wanted to go over one problem from the review before your test tomorrow. Problem 13 right here, because it has a lot of the different parts of what we were talking about. So it says the differential function, which is right here, it's a derivative. I mean, you can think of it as y prime if you want to. However you want to think about it, but it tells the derivative, gives a rate at which Elliot walked across the classroom floor over 4 seconds. How far did he walk backwards? Well, let's see what this looks like. If I put this function in here, it is 3x squared minus 10x plus 5. And I'm only looking at it over the first 4 seconds, so I'm going to put 4. And I don't know what the speed is, so I'm just going to go ahead and put 10 to negative 10, because he might be going backwards or forwards. And I hit graph. So there we go. Well, we have area here where he's going positive, negative, positive. So it's a lot of positives with some negatives though. But the question specifically asks how far did he walk backwards? Well, that's just this area right here. It's just the area under the curve. So I need to know how much area is there. Well, all I have to do is integrate that, but I have to get these boundary points right here. So these boundary points are where it crosses. Couple things I could do. I could trace, and if I trace over here, it looks like it's at about 0.61, and I could trace all the way over to the other side, and I could do that, which is 2.7. So from this point in time to this point in time, he's walking backwards, and if I put those in there and integrate it, I will get this. All right, a couple other things you could do. If you want to get more precise on that, instead of tracing, right above it, it says calc. So you hit calc, and you're looking for a 0. And I'm going to put a left bound here and a right bound here. And between those two marks, there's definitely a 0. And I think it's about right there. My calculator is going to take my guess and make it exact as much as it can. So that's where that number comes from. And now there's a 0 over there, so I'm going to hit second calc again. And I'm going to go way over here, and I'm going to find the 0 by doing just what my calculator asked for. My calculator asked for a left bound. All right, well, there's a left bound, there's a right bound, and somewhere in there, there's an intersection, and right there it is. Maybe we can get the calculator to shade this too. If I hit second calc and do the integral, I could do the lower limit right there at 0.6, and I could come over here. Let's see what this shades. I'm not sure if it's going to shade what we want it to shade here. Oh, it did. It shaded everything, and there's the area shaded, and there's the distance. It's negative, but we know it's backwards, so we're just talking positive. And if you go back to the home screen, you can hit Math 9, and you can integrate that function from there to there. I'm not going to waste time typing it in because I know it's already typed in, so I can just do that. My calculator will integrate it there. All right, this problem has a lot of the features of the calculator you need to know for your test.